There we go. Okay, so polynomial function is in that lovely little form there. Doesn't that look like fun? Not so much. The coefficients a sub n minus 1 are real numbers. What's a real number? What is it not? Or it is not imaginary. Sometimes it's easier to think about what it's not as opposed to what it is. Where a sub n is not equal to 0, why can this part right here not be equal to 0? What would happen to this whole term if the a sub n part were equal to 0? It would be gone, right? Because 0 times anything just goes away. So that's why it can't be 0. So that's why they always say stuff like that, just so you know. N is a positive integer, so in polynomials we don't have negative integers, we have positive integers. And then key, I would highlight the no negative exponents just so you get that part down, okay? Because you want to make sure you get that so you can understand the difference between the two. So we're going to write the verbiage below that stuff in a second as soon as I get back to that place in my notes. So we are going to say polynomial functions are smooth curves. If you haven't got your calculator out, get your calculator out. Because we'll be doing a bunch of calculator stuff later on. Smooth curves with no breaks or gaps. And they're continuous for all real numbers.
Might be confusing because you're writing.
I know. They'll just have to get over it. The highest exponent, it is confusing, I agree. So that's the end of the shape and continuity piece, right? And I just ran out of room because I write big, but you'll get over it. The highest exponent, n. Of a polynomial is the degree. Okay, so the hardest one I think when we classify here is the very first one because there's an implied exponent with variable in there. Can anyone tell me what variable and exponent should go right here? 1. This one's a 1. It's a good guess. What should it be right there? What would just not do anything to that? If I multiply 2 by what number, what makes it stay 2? 1. So x to the what power is 1? X to the first is x. X to the what is 1? 0. Good. So we can write an x to the 0 power there. And you just kind of have to know that. And that's kind of annoying that you have to know that, but that's the way it goes. So you just got to get over it. So what's my degree here? What's the highest exponent? 0. What's that called? I know, right? Weird. It would be like y equals 2. What is the 2? Anybody know? I give you a CO. Somebody just said it. Constant. Good. Right? The constant is just the number part. Okay? And then you want to think about shapes of the lines or curves. And that'll help you figure out what it should be called as far as the classifying goes. So this would be a constant monomial. Do you remember how many terms a monomial is? One term. Binomial, trinomial, polynomial, 4 or more, right? So monomials 1, I'm only going to write the first part by degree because I expect you guys to know that monomial, binomial, trinomial. So if you didn't know that, write that down so you can remember it. Okay? So what degree is the second one? What degree is the second one? 1, right? So it's 1 right here. So degree is 1. What's that called? What shape would that graph be? Linear. Okay. Next one is, degree is 2. What's that called? It is a parabola, but it's specifically quadratic. Way to go, Luke Holmes. Quadratic. 2 to the third power is called what? I think somebody said it. Sometimes you guys say it so quietly, it's hard. Cubic. I think of a cube, right? Like a cube has 3 dimensions. That's why it's cubic. If that helps you, it helps you. If it doesn't, then oh well. I tried. 4 is called what? Quartic. I think of 4 quarters in a dollar to remember quartic. And does anyone know what 5's called? Quintic. Was that Luke again? He's on fire. Okay. We spend a whole ton of time doing like as x approaches infinity, blah, blah, blah. So I'm not doing this part. Okay. You know how to do that already. We're going to do more of it later on. And then you'll get it as a result. So I've got a little quick thing which will help you understand the shapes of these graphs. Okay. So we're going to write it like this. We have positive. If we have a positive x squared, if we have, then it looks like this. And it goes up. Actually, I'm going to write it below. It goes up, up. And I just don't want to write the whole as x approaches infinity, y approaches infinity, as x approaches negative infinity, y approaches infinity, because it's annoying. Okay, so I'm just writing up, up. And you guys know how to do it with the x approaches infinity thing. So it's just easier for shorthand for this little example. And then we're going to have negative x squared. And it's upside down when it's negative x squared. So then it's down, down. And we're talking about the end behavior here, which I did not make clear. Okay? So up, up, down, down. And then I like to think about this, right? So the only reason I wrote squared is because you guys know what those graphs look like. So what it means that squared is any even exponent. So if I had x to the 100th power, it's the same damn thing. If I had x to the 22nd power, same damn thing. Remember, when you graph those things, it just kind of flattens out at the bottom of the graph. The higher the exponent is, it looks rectangular at the bottom of the graph. So we'll practice a little bit of that when we get to the graphing calculator portion of the program. But I like this shorthand, right? Because I understand 2 is an even number because it's easy to understand. So now we're going to do to the third power because that's easy to understand as well. And then the graphs do all sorts of weird crap in the middle. But we're just talking about what happens on the ends. So that's why I think this is a handy little thing to do. And if I were in my own class, I would make flashcards with this stuff. So notice I only drew 1 arrow on that thing. So I think of a human being that's positive and odd, right? Does anybody have a positive odd friend? Like they're a strange person and they're positive? I do. See, it's a high school thing that you do. Good. It's usually not many, right? So positive odd person is like strangely happy. They're like, woohoo, yeah, I'm having a great time. And you're like, what are you talking about? Why are you having such a good time? Right? So they finish up. Positive odd person finishes up. Anybody know a negative weird person? Think of a human being you know that's a negative weird person. It could be your mom or dad even, right? Could be brother, sister. Negative odd person is like the Debbie Downer kind of person. Oh, this sucks. My life sucks. This school sucks. All that kind of crap, right? Negative odd person. And they finish down. So that's how I remember, right? I do all those little tricks to help me remember these things because then I don't have to think about it too hard. So if it finishes down, oh, that was too ugly. If it finishes down, it looks like that, right? And you can make a nice little arrow thing at the bottom just to... So what is the end behavior for positive x cubed? Up, down, or down, up? Somebody say it. Is this top one positive x cubed, up, down, or down, up? Down, up. And then the negative x cubed is up, down. And again, we could do the whole as x approaches infinity, y approaches, but it's easier to just do up, up, down, down. Okay? So what do you notice just with the wording up, up, down, down, up, down, between even and odd exponents? Math is full of patterns, so we want to recognize those patterns, right? Because it makes math easier. So odd exponents are always what? And even exponents are always what? Look at it. You can do it. Positive is either up, up, or down, down. So it's the same, right? And if it's an odd exponent, it's always one of each. Either up, down, or down, up. So more you can recognize things like that, the easier it is. So I got kind of loose on the whole sign in, sign out thing. You got to sign in, sign out right there.
Can I?
Yep, totally. Just because in case something bad happens in school, we need to know where you are, right? That's why. And I got kind of loose on it for my senior classes, but we really got to know where you are. And you got to do time in, time out as well, and be accurate with those times. In case something bad happens, that's why we have to know. And we don't like thinking about school shootings and stuff, but that's why. Okay? Super happy moment, right? But we had this scary moment in this class, right, with the firecracker thing. And I looked, especially Malone had those big saucer eyes, and she was freaking out. And I'm like, I got this shit handled. Do you remember that? It was very exciting. Okay, so you're going to do 1 through 6 on your own and write up, down, up using this little thing I wrote on the side as a guide. I'm going to freeze the screen. I'm going to write them all down. And then we got a little practice time for you just to get this stuff down. No pun intended. Don't be lazy, do it. Don't be lame. And then I'll display my answers in a sec, and you can double check if you're right. I'll make sure I got them right. Yep. Yeah. Tell me when you're ready and I'll show you my answers. If you need a minute, take a minute. Just do it, right? You want to be able to think about this stuff and like get it quickly, right? Because pre-calc is hard and the problems are involved. And this is like a little tiny part of one problem. And you'll see. I like talking about it, yeah, so talk about it in your table group, so that's why you're in the group, so you can talk and help one another. So we technically could pause the recording. Azur's all by himself today. Lonely young man. Yeah, but who cares? Mm-hmm. Sometimes it's amusing. Sometimes not. Yeah, how was it? Oh, nice.
He's like, I want to hear it too.
Oh, yeah, that's good. And?
It's not as bad as...
See, that's like, I wanted you to hear it because it was good, right? Because it'll help give you confidence as well, which is always a good thing. Because it was good.
Was it?
Yeah. And that, it was like the perfect teachable moment right there, that whole thing that happened in Algebra 1, to be like, I realized, oh crap, it's not good, and then what I did about it and how good it was after. And again, you can do that too, like no problem, right? And again, the pacing is the hardest part, especially in this lesson. That's why I wanted you to do the thing this morning, is figure out like how much you wrote down versus what I'm going to do in here, right? But think about that as you go, right? So you're like, And you can write everything down because sometimes that helps you learn it. But like how much you're going to be able to teach so you can make it to the end of the lesson. And you're kind of paying attention to the time as you go. And you probably be looking at the clock, and mine's more internal because I've been doing it so long. I can like feel the time. Yeah. I'm like, we're about done, aren't we? Uh-oh. And then I'll rush through an example or two at the end. And my timing wasn't great first period with this lesson because it's 2 of those videos, so it makes it harder to get through enough so they get it. Are we good? Enough babbling? Raise your hand if you got them all right once you check them. I want to see how many people got them all right. I did too. I'm proud of myself. Sometimes I screw up. It's okay. That was a lot of people who got it all right. Good job. Did anyone miss one where you're confused why it is what it is? Number 5. So right here, positive. So we're looking at this one right here, right? Positive odd. Finishes up. Positive odd person is like unusually happy, so they're up all the time. So they may start down in the morning and then they're like, woohoo, life is great. And you're like, why are you so weird? Okay, we good? Yeah.
Can we write it like that in our homework?
Up, down, down, up. You can write it like that in your homework. On the test, I'll make you write as x approaches infinity, blah, 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 blah. On homework, you can write it like that. I know. It's so much better like this. I like it. I get irritated writing that as x approaches infinity thing as well. I get sick of it. That's why I'm doing the up, down, down, up thing right now. MJ?
Do you have to add the exponents or is it only the first?
No, you don't. It's only the highest degree. So the highest exponent is the one you go by. That's a good question, right? So, because sometimes they'll write them out of order, right? And we'll do that to you guys on purpose. So you have to recognize it's out of order, rewrite it in standard form. Anyone remember standard form of a polynomial? What's the rule? Highest exponent, next highest, next highest, next highest, and the number at the end. There's usually a number, not always, but usually a number. Now, if I look at number 7, is the coefficient positive or negative? So the number in front of x, is it positive or negative? How do you know that? Because it finishes down. Yes, good. So the leading coefficient is negative. What's a leading coefficient? Number in front of the
variable.
Which variable, though? Because you could have 6 variables.
Is it the one with the highest?
The highest exponent. Perfect. Leading coefficient is a number in front of the highest exponent. Okay? So the variable with the highest exponent. So our leading coefficient here is negative because this finishes down. Is it even or odd? Is it odd or even exponent? Odd, right? Because it's got one of each. That's how you know. It's got one up, one down. It's always going to be an odd exponent. So you know how sometimes, have you guys realized this yet? You really should make flashcards sometimes in pre-calc. If you haven't realized that yet, you should be making flashcards in pre-calc. Where you guys are seniors and all the juniors are gone right now, but juniors and seniors, we expect you to make flashcards when you need to make flashcards. And when you get to calculus, if you don't make flashcards, you're screwed, right? What's nice about making flashcards, especially in pre-calc and then in calculus, is that we'll make flashcards. When I took calculus, I made flashcards for every single chapter. And even when we were on the next chapter, I would study the old flashcards because then I kept that stuff fresh in my head because calculus is freaking hard, right? You'll be amazed how hard it is. But what's good is you can understand it. And once you understand it, it makes you feel smart. But you need to employ all these study strategies that I've told you. I said that yesterday in this class, right? Or not yesterday. Yeah, it would be yesterday for this class, right? And I say these things repeatedly because these are strategies you should be employing, right? So make a bank of flashcards for chapter 3. Keep that bank of flashcards. And once we get to conic sections, which is actually chapter 9, then you'll have the bank of flashcards from chapter 3 and continue to study them. Because what will it do? It'll make the final way easier, right? Because you keep that information fresh in your head. Okay, so think about the study strategies we tell you to use and use them because they will help you do better in the class. And because once you get to college, you have to get really good grades, otherwise you can't get a job. They'll have minimum GPA requirements to interview for a job, like 3.7 is a common minimum, right? And I'm not going to have people raise their hand. How many people have 3.7s? Do not raise your hand. But you can think in your head if you have a 3.7 GPA right now or not. And if you don't, college is twice as hard as high school. So you better step up your game, right? And using these strategies will help you to step up your game. So do we have positive or negative leading coefficient here? On number 8, positive because it's up. So positive coefficient. That is not how you spell coefficient. Coefficient. And is it even or odd? See Sam in the back? He's like, even. Exponent. I don't think I've ever seen him have a wrong answer up either. It's a good challenge. Now it puts pressure on him a little bit, huh?
Like every time.
Got to keep it up now. He's like, oh shit. Right, so turning points. What is a turning point? Remember I used to like, well, not used to, I still like it. Draw the little roller coaster car. Is it increasing or decreasing, this roller coaster car? It is increasing. Is it increasing or decreasing over here? Decreasing. So a turning point is when it changes direction, right? It's when it goes from increasing to decreasing. That is a turning point. So because on this graph there are 2 turning points, what is it? X to what power? 2 turning points. You already know because you can look right up here, just saying. Right? Look right up there. It's x to what power? 3rd power, right? Oh, we're tying it all together now. Isn't that nice, right? So there are 2 turning points. The degree is what? What's the rule then? How does the exponent, the highest exponent, compare to the number of turning points? How many turning points are in this one right here? 2 of them. So it's always 1 more than the number of turning points. Okay? Now that doesn't work every single time because if I put x to the 8th power in your graphing calculator, again, it'll look like a rectangle at the bottom. So, but that's the general concept. It's called the point principle. Right, so number of turning points is 1 less than the highest degree of the function. Okay, so if the turning point is higher, it's called a relative maximum. It's relative because there's 1 high and 1 low point. It always irritates me that they call it relative, but whatever, they call it relative, so get over it. Yeah, I know. It's just irritating. Just call it a min and a max because that's what it is. Doesn't matter if there's 1 of each. Because we'll do problems where you have 2 maxes, 2 mins, right? If I had 2 maxes, 2 mins, what would the exponent be? X to what power? Good, 5. Nice, that was quick. Right? Because I'd have 4 turning points if there are 2 maxes, 2 mins, and the exponent is 1 higher. Right? So the exponent is always 1 higher than the number of turning points. I can't even say always though, because again, like I said, x to the 8th would look like a rectangle at the bottom. Chase is looking at me like I got 2 heads right now. Okay, so the max and min points are called extrema because they are extreme, right? It's up really high, and it's down really low, so they're called extrema. Turning points are where the function is increasing and decreasing. I already talked about that. Okay? So sometimes I'll do it in different order than Gina because it's more relevant at the time. Throw that in your graphing calculator, x cubed plus 5x squared minus 8x minus 1. And we're going to do the max and mins with that stuff. So we're going to throw that into the old graphing calculator. You good? All right, so we got x cubed. Remember, sometimes you got to hit the right arrow after x cubed. I frequently forget, and it irritates the crap out of me.
Anybody else?
So throw that in the calculator, hit graph. Your graph should look like this once you do that. You can look at your paper if you need the rest of the graph. If your graph doesn't look like this, hit zoom 6. It'll take it back to a standard window. So if you forgot that, write that down as well. Like zoom 6 gets you back to a standard window. Like all that kind of stuff will help you do your homework. Connor, you can drop that blind. You're like in the spotlight. You're okay? Okay. That seat, like at this time of year, it just cooks you guys. Are we good? Anyone need help on this portion of the program? Need to charge it? Yeah, all good. Okay, so I need to see that maximum, right? Because the maximum's off the screen. What do I have to increase? X min, X max, Y min, Y max. Y what? Yeah, don't be scared. I saw that little look of fear all of a sudden. What's your guess as far as what I should increase it to? So don't do 20. Go big right away because it irritates the crap out of me. I used to do that. I'd be like 20, didn't work. 25, didn't work. 30, didn't work. So we're just going to go 50 because I know from first period that 50 works. So we're going to go 50. Window, which is right here, and change the Y max to 50. So you go window, Y max 50. Okay? Now we have to get the maximum. Okay? To get the maximum, you go second trace number 4 is max. So right here, you go second trace, and then you go number 4. You can just hit the number 4 on your calculator, and I'll show you up here. Second trace number 4. That one right there. Then it asks you the question left bound. Mine shows top middle, yours shows bottom left. So second trace max. Everyone have left bound on their calculator right now? Because if you don't, it's a good time for me to help you. So second trace number 4 is what you're doing. Second trace, hit number 4 on your calculator. Left bound. Notice I want to get this maximum. My little cursor is not anywhere remotely close to where it needs to be. So for me, I have to, you guys, many of you can just hold the button down. This one I have to hit the button 8 million times to make it go over there, which is annoying, but whatever. So am I on the left side of the high point? Yes, I am. So I hit enter. Then it asks me the question, right bound? I'm not on the right side of the highest point, so I need to move my cursor over to the right side of the highest point. Okay? Then I hit enter once more. Your calculator will say guess, mine doesn't. Yours says guess. You don't want to guess, you want to know, so hit enter again when it says guess. Okay? And you should get negative 447. You might have negative 3.99997 right at the end, and it will always round to the correct answer. You might have negative 4.8 zeros and a 1 at the end, but it will always round to the correct point. Okay? So that is our maximum. On your little note sheet where it says relative max, you write negative 4, 47. Okay? Yes?
What if I was like kind of off? Like I got negative 3.8 for X and then I got.
You were on guess and didn't hit enter.
No, I did. I hit it twice.
Lies. You didn't move it to the right side of the max. You got to go left side when it asks you left bound.
No, I did.
You didn't. Lies. I will help you.
I'm redoing
That's my job. Do it so I can see you do it because it'll be better. Left bound. Where? You're surrounding that top thing. That's why. Now enter. You could do it way down there and still work.
Okay, so
Just a second.
and then
I see.
I see. That makes a lot more sense.
Yeah, good.
Never mind.
Yep.
I forgot that we're supposed to surround it. I just went
Trace number 4. And then your cursor is off the screen right now. It's at 4. So we see how that exercise is increasing. Enter. I'm on the left side of the high point. And then I move over to the right side of the high point. Enter. You're surrounding that top, right? So I hit enter over here and enter over there. Then it says guess. Yep. You don't want to guess. You want to know. And that'll round to negative. Yeah, when it just gets into range more. Anybody else need help on that? You good? Get the minimum. Second trace number 3 to get the minimum. You can check on mine to make sure you did it right. It always says left bound first. And round to the tenths on these. It's just a pain in the neck to write if you round to hundredths. We're going to round to tenths. So you should get 0.7, negative 3.8. So I'm going to sketch this graph onto my notes kind of over here. What kind of function is this if I'm classifying it? What do I call it? By degree. The highest exponent is what? 3. What's that called? Trinomial. No, that's number of terms. Trinomial. Yes, good. Cubic. It's a cubic what? There are 4 terms. What is 4 terms called? Monomials 1, binomials 2, trinomials 3. What's 4? Polynomial, yes. Good. So this is a cubic polynomial, right? And we'll just periodically test you on that so you get that stuff in your head. But we're not going to spend a ton of time going over that because you should know it. So if you don't know it, write it down. You could write down right above it, that's a cubic polynomial, because we will ask you that question on your quiz and your test. Cubic because the highest degree is 3. Polynomial because there are 4 terms, right? 4 or more is polynomial. What's trinomial? 3. How do you remember? Like what's a trick to remember? Tricycle, 3 wheels, right? How about binomial? Bicycle, 2 wheels, right? 2 terms, 2 wheels. Trinomial, tricycle, 3 wheels, okay? Good trick to remember, makes it easy. Okay, so when we do intervals, are we talking about x values or y values? X values. So if you forgot that because you're a knucklehead, write x values down here so you remember. See, so now, like right now I'm thinking about the pacing, right? And I know I'm about 3/4 through the period, so I don't have a whole lot of time left, right? So I adjust like as accordingly, right? Because we've already done most of the work involved for the problems below. So first period I did x to the 5th. It was a mistake because there are too many ups and downs. And when I was doing the intervals, I ran out of time and I was making mistakes. And then I was like, screw it. You guys know what I'm doing, so don't worry about it. But that's like what I'm thinking along the way, right? Okay. So we're thinking x values. Knuckleheads in the back. We're thinking x values. What is this x value right here? -4. Way to go, Luke Holmes. What's the x value right here? 0.7. Because we're doing intervals now, right? So if I were to write something over here, what could I write over here for an x value? Weird question, right? What could I write for an x value right here?
-47.
No, that's a y value. Nice try. X value. What x value is all the way to the left forever?
Infinity.
Negative infinity. What should I write over here on the right side then? Positive infinity. And I like putting the plus. And then I'm, again, thinking about the little roller coaster car. Is it going uphill or downhill right there? Up. Where's it going down here? Down. And then on the other side, it's going up, right? I just like to draw the car because it helps it make sense. What do you need?
Is this in the packet?
This is in the packet, and we're recording the lesson. It's right after the first section. We added 5.2, and this is 5.3.
Okay.
Okay? And you can check. We'll have the video posted.
All right.
Okay?
Thanks.
So increasing, very nice. I love you. It's increasing from where to where at first. We go left to right with intervals. So the leftmost increasing interval is what? The leftmost increasing interval is from where to where?
From negative infinity to negative 4.
Negative infinity to negative 4. What's the next one? Where else does it increase?
0.7.
Yes, 0.7 to infinity. Very good. Okay. Where does it decrease between what two values?
Negative 4 and 0.7.
Negative 4 and 0.7. Very good. Now, I don't think Gina makes you square off the brackets here, but she doesn't? Okay. So you could square them off if you want. I won't mark points off because it includes that value. I think you probably should square them off, but I don't think the textbook makes you square them off either. We're just saying between what two numbers it is increasing or decreasing. So it's not to that level of detail, but if you want to square them off, go for it. Totally fine. Okay, so this thing, students are reluctant to draw this over here. That makes it so much more clear. And I only write x values, again, I only write x values for intervals, right? So it's important to write only x values because then it's just so much easier to write the intervals. If you try to do it from these points up here, it's kind of a nightmare. Especially when you have like two increasing, or you have two maxes and two mins, it gets really confusing. So don't do it that way. Let's do, what do we have? We got 15 minutes or 13 minutes. So let's do number 3. That's the only one we're going to do because we already taught you everything you need to know. This is for just practice. Do you guys want to try it on your own? And then I'll just write answers up here, or do you want me to explain it as well? Explain it as well? Okay. So if we had to classify this by degree and number of terms, what would it be? Fourth degree is what? Quartic. Yes, good job, Grayson. Quartic polynomial. Feels good when you get it right. Okay. Domain for any polynomial is what? All real numbers. Now this is a positive quartic. What's the end behavior? Up, up. So we don't know what the bottom of it is yet, so we can't do the range yet until we put it in the calculator. Can we do anything else? We just said end behavior, so we'll just write up, up right there. And then we don't know the max or the min or the intervals, so we got to put it in the calculator to get that piece of the program. So let's do that. Remember, you got to hit that right arrow on some of your newer calculators. Okay, so throw that in the calculator, hit graph. Remember, our window is still jacked up from the previous problem, so hit zoom 6 to get back to a regular window, and your graph should look like that. Okay, so get that in there. I want to wait till everybody has that graph in there, and then we'll move on. If you already know what to do, what's the first thing, a min or a max going left to right? What is the first thing going left to right, a minimum or a maximum? That's not the answer to the question. The answer to the question is minimum or maximum.
Oh, maximum. Wait,
Minimum, right? It's got a low point first, so it goes second trace number 3 to get the minimum. And then I'll be writing them up as you go. So you guys can kind of do it on your own, but I'll still kind of explain what's going on. So first minimum, I go second trace min. You could also, on this graph, if I zoomed it into like -4 to +4, it's going to be a little easier to do. So x, I'm going to make -4. And y, I'm going to make +4. You don't have to do this. It just makes it easier to see what's going on. I could make -3 to +3 as well, but I'm not going to go crazy with it, right? It doesn't matter. So second trace number 3 for minimum. I go on the left side of that first low point. Then I hit enter, and then I move it to the right side of that first low point. And I should get negative 1.1, negative 1.0, negative 1.1, negative 1.0. And I'm going to draw it over here. So, but I want to write it here as well. Minimum, negative 1.1, 1, negative 1.0. And then I'm going to get my maximum next because that's the next one in line. So second trace number 4. Surround that high point with your cursor, left bound, right bound. And you should get 0, 1 for that next one. That's a maximum. And then minimum is the last one, so second trace number 3. Remember, you can start up really high. You just have to surround that low point. So you can start high and, you can be like way off when you choose your cursor points. Doesn't matter. The calculator figures it out. I try to do the same relative height surrounding. So 1.8, negative 7.3. That's the minimum. So we can do the range now. If we just write it like greater than or less than, what's the range? Where does it start? Or we could do it in interval notation. Sometimes you guys like that better. What's the lowest point on this graph? And you're thinking about y values with range, right? What's the lowest y value we just got? Negative 7.3. So my range, I'm just going to write it like this, right? Because the graph is greater than that. And I'm going to write negative 7.3. So notice I'm writing range in like a number of different ways. We've done interval notation. We've talked about set notation. Now we're just writing it as an inequality. All of those are correct. I'll accept any of those on the test and the quiz, just so you know. So if you like writing it one way or another, write it that way every time. It's fine. I recommend choosing the same method every time. So if I wrote that in interval notation, because some of you guys like that better, I'll show you what it looks like. So what goes on the left? Is it squared off or not? No, right? So I'm writing it like this because it includes negative 7.3. It's got to be a bracket. And then it goes to what? Positive or negative infinity? Positive infinity, right? Because its graph's going up. Positive quartic, it goes up, up. So positive infinity. So if you like writing with the interval notation like that, that's totally fine. I don't care. I think that I wrote that in the wrong spot too. That was a special moment. Oh, it's not going to grab it. There we go. I want to write it up there. I'm going to just put it up here so it's easier to see. And then I'll just draw an arrow. A hot pink arrow. Because, Okay? So that's interval notation. If you like writing it like that, the set builder notation I find annoying. Why such that blah, blah, blah. It's just irritating. So I don't write that. Okay. So over here, I got my graph that looks like that. I made it look like a W. But so we're thinking x values, what goes on the leftmost for x values? Negative what? Negative infinity. What's this first low point we have? So it's the smallest minimum value on the x, negative 1.1. What's this high point right here? So the x max is what? 0. And then what's this low point right here? Negative 7.3. Nope. 1.8. There you go. It's really easy to F that up, right? Like you're on fire and then damn it, I picked the wrong one, right? It's irritating, but it'll happen. So you always want to go back, because this is confusing, right? Writing it out like that, but it'll help you to write the intervals. So I would go back and make sure after I write them that I only chose x values. And then that's a good little built-in double check. So you could write right here, check for x values. Check for x values only. Like if that makes sense to you, write it. If it makes sense to you, write it a little bit different way. Write it a little bit different way that makes sense to you. Okay? So what's our first interval? Is it increasing or decreasing? Decreasing from what to what? Negative infinity to negative 1.1. What's our next interval? Increasing or decreasing? Increasing from where to where?
Negative 1.1 to 0.
He's like, damn it, right? And then the next one decreases, right? From where to where? 0 to 1.8. The boys back there are actually in 7th grade mentally. And then it increases where?
From 1.8 to positive infinity.
Yes, very good. Okay, so 4 different things, right? Because it's x to the 4th power. How many turning points on this graph?
3.
What's the end behavior?
Up.
Just me challenging you, right, to just think about it, right? I just want you to think about all this stuff. So should the number of intervals match the exponent? Ooh, that was like, you could hear a pin drop right there. Should the number of intervals, how many intervals did we have right there?
4.
We had 1, 2, 3, 4. Did it match the exponent?
Yeah.
How about when we did this one up here? How many intervals did we have?
3.
3. Did it match the exponent?
Yeah.
That's another good way to double check, right? Make sure you have the same number of intervals as you do the highest exponent. Will that always work? It won't necessarily always work because if we put in, let me show you that since I've talked about it, and then we'll get your question in a second, Azure. If we put in x to the 8th, I just want to show you what it looks like. Right, so it just way flattens out at the bottom there. So then it's not going to have like 7 different ups and downs, right? So it doesn't always work, but the ones we give you on a test, it will work like that because it's better for us if we give you a curvy graph because then you can identify the increasing and decreasing intervals easier, right? I'm not going to put, like if I was teaching your advanced pre-calc, I would mess with your head in just a whole number of horrible ways, right? But this is regular pre-calc, so we make it like transparent and obvious what we're trying to do so you guys can do better in the class, right? And that's why, in my opinion, regular pre-calc's better than advanced pre-calc because I teach the crap out of you, right? I teach you every little step and show you all the little tricks. So when you get to calculus in college, you can use those tricks and it'll help you do better. All right, do you have a question? Just calculator thing? All right, any other questions about the lesson? Because I'm going to stop this video. We good? Okay.